Chapter 6, Normal Probability Distributions. Under this chapter, we have three sections: 6.1, 6.2, and 6.4. First, I will do section 6.1, the standard normal distribution. But before that, we have some review. Under that, we have two parts. First thing you have to know, what is a discrete random variable? Okay. Actually, in chapter 5, we learned about this one. What is a discrete random variable and what are the properties of that random variable? I will just do it again. Okay. Actually, if you have a discrete random variable, it can take either finite or a countable number of possible values. For an example, we can say if you toss a coin, what are the possible outcomes? We can have only head or tail. So we have only two possible outcomes. That means we have finite number of possible values. Or if you want, you can count like 1, 2. Okay. Another example is rolling a die. If you roll a die, how many possible values we can get? We have 6 possible values, 1 up to 6. Okay, so if you want, we can count, or it is a finite number, it is a countable number. Okay, then if you want to draw a graph for your discrete probability distribution, it's really simple. It will be a bar graph. According to each and every possible value, you will have a separate bar. Okay, then there are some requirements for discrete random variable. We did this part in last chapter also. First requirement is, if you add all the probabilities of your probability distribution, it should be 1. Okay. The second one is, if it's a probability value, then definitely it should be in between 0 and 1, or it can be 0 or it can be 1. Okay, then the next one is, what is a continuous random variable? Actually, uh, if you have infinitely many number of possible values, we can say it's a continuous random variable. For example, we can say the number of possible values in between 1 and 2. So if you have a data range like 1 to 2, how many possible values can we get in between those two values? Actually, there are infinitely many possible values like 1.1, 1.3, or if you want, you can take 1.35 or 1.5T, 5234 or 1.67. Likewise, can you see, there are infinitely many possible values. Okay, so then if you want to draw a probability distribution for that continuous random variable, is that possible? No, because you have lot of x values. So how can you find each and every probability value for your x value? It's really um, impossible. That's why we need another alternative for this one. So actually, if you have a continuous random variable, it's really difficult to construct a probability table. So in this case, we will use a graph for that. Okay, that graph is called a density curve. Okay, actually the graph of a continuous probability distribution, that means fx is called a density curve, or we can say probability density function, pdf. Then if probability density function, it must satisfy these two properties. um, First one is, the total area under the curve must equal to 1. I will show you what is a density curve. Okay, actually this is an example for a density curve. So the first requirement is, the total area under the curve, That means this red color curve should be 1. Okay, then the second requirement is what? Every point on the curve must fall at or above the x-axis. So this graph should be at or above the x-axis. It can be below the x-axis. Okay, so that is your second requirement. We have two requirements. Okay, then next thing is we know this total area under the density curve is equals to 1. Actually, there is a correspondence between area and probability, because if it's a continuous random variable, we have area, and if you uh, get this total area, it should be 1. But if you have a discrete random variable, we know if you add all the probability values, it should be 1. Okay, so there is a correspondence between this area and that probability. Okay, then next one, area and probability. Actually, these two things are exactly equal in this chapter. Area is equals to probability. So please remember, in this chapter, if you want to find any probability, the meaning of the probability is you have to find the corresponding area, okay, under the curve. Okay, then what is this? Probability of getting x values in between a and b. Here, this is the density curve. So the probability of x values in between a and b. So this is the corresponding area. So if you want to find the probability, you want to find this colored area. Okay, then what is next? The total area under the PDF. Yes, what is the value? It should be 1. So if you write it as expression, it is this: the probability of x values from negative infinity to positive infinity should be 1. Yes, that means the total area under the curve should be 1. Then next one, the area under continuous curve at any point, or it can be A or B, at any point is 0. That means if you want to find the probability of any single point, you don't need to find it. It's just 0. Why? Because if you want to find area, you need some surface. But if it's a line, you know we cannot find area of a line, because here we have only one point. So we don't have an area. We have a line. So the probability of any point in this continuous curve should be 0. Okay, then next one, it's what? It's uniform distribution. Actually, one of the good example for continuous distribution is uniform. There are some other distributions also, normal distribution, like gamma distribution. There are so many distributions, but this is very nice and very simple distribution, uniform distribution. What is this? Actually, in here, a random variable is uniformly distributed if its values are spread evenly over the range of possibilities. Can you see, if you take any x value, the probability of getting that x value is same. That means it uniformly distributed if its values are spread evenly over the range of possibilities. So that means if it's a uniform distribution, definitely you will have rectangular shape. It can be square or box. Anyhow, it should be like box shape. Okay, rectangular shape. Then the height of the rectangle is this. Okay, 1 over b minus a. Okay, what is the height of your rectangle? It's this. This length. It's our height. Here you have it's 0.5. But if you want, you can find this value using these a and b values. If you know a and b, then you have to do is 1 divided by b minus a. Then definitely you will get this height. Okay, we'll see. Can we get this one? Okay, we'll check. 1 divided by b minus a. Our b is 125, a is 123. So the difference is 2. So 1 over 2 is 0.5. Yes, it's correct. The height of the rectangle is 0.5. Okay. Then we have a small example. Okay, one example, but it's very simple. If you know how to find this example, that means you can do any uniform distribution question. Okay, what is this? Find the probability that a randomly selected voltage level is greater than. Here it's not that. Okay, here it's than. THAN, greater than 124.5 volts. Okay, now I will show you how to find this one. Okay, um, in here you have to find the probability that a randomly selected voltage level is greater than 124.5 volts. Okay, first I will draw the graph. Here we have x-axis. This is the probability of getting x. Then here it's 0.5. Whole area is 1. Here the value is this. This end it's 125. Okay. Then we want to find the voltage level is greater than 124.5. So it will be in between these two values, 123 and 125. So I will mark it in here. Then draw a line. Then you want to find what? Greater than. That means you want to find this area. Okay. Why? Because you want to find the probability that a randomly selected voltage level is greater than 124.5. Okay, so this is the thing you have to find. So tell me, how can we find this area? You know this value. What is the length? You can subtract 125 minus 124.5. It will be 0.5. The height is also 0.5. So what is the area? 0.5 times 0.5. It will be 0.2. Okay, so what is the answer? You can write this way. Probability of x greater than 124.5. Voltage is 0.25. Okay, that is the way of how to find this value. Okay, okay, then I will move on to next example. In here you have to identify the area or areas under the curve that correspond to the probabilities. Okay, so here we have 4 questions. You have to find the corresponding area. Actually in here the area of this part is simple a. Okay, it can be any value, but I just mark it as a. Here it's simple b, here it's simple c. Okay, now we have 3 areas and we can find these probability values using these symbols. Okay, okay, for the first one you want to probability of x greater than 5. What is the corresponding area? So okay, I will draw the curve here. Here it's the area is a. Here it's B, here it's C, here 2, 5. Okay, so probability of x values greater than 5. So you have to find the value of this area greater than 5. So it will be C. Second one, the probability of x values less than 5. What is the value? Here this is 5. So now you have to find the areas less than 5. The area under the curve less than 5. So this one and this, both areas, okay? So you have to add A plus B. For the third one, you have to find the probability of x values in between 2 and 5. This is 2, this is 5. So you have to find the area in between 2 and 5. The x values in between 2 and 5. So this is the area. It's P. The last one, you have to find the probability of x values less than 2. Remember, the probability means area. So if you want to find probability, that means you have to find the corresponding area. Here, x should be less than 2. So this side, so the area under the curve is only this part. So it's A. Okay. Okay. Now you know how to find these areas if you have these values. Okay. Then we have another example. In here, you have a continuous random variable x and it has a symmetric shape. Okay. So it's a symmetric distribution. You know what is the symmetric means. Okay. Symmetric means if you draw a line here, the 50, it's our mean, then this side and this side will be exactly same. So the left side is mirror image of your right side. So both sides are exactly same. Then it's a symmetric distribution with mean 50. Okay. Now suppose we know that this value. What is this? The probability of x values in between 50 and 80. Yes. So the probability of x values in between 50 and 80 means what? Probability means the corresponding area. So what is this area? It's 0.35. We have that information. Okay, now you have to determine these 4 parts. We have A, B, C, D, 4 parts. I will show you how to do those 4 parts. Okay, here you have to find this, okay, the probability of x values in between 20 and 50. So you can see the picture according. Okay, I will draw the picture here. It's a symmetric one. Okay, that means this is symmetric around this mean. The mean of the distribution is 50, so it will be here, the middle place. Okay, then in this side we have 20, the same distance. Okay, here we have 80. So the area of this part is 0.35. Okay, this is a symmetric one, so you know what is the value of half. It's 0.5. This side also it's 0.5. So if you know it's 0.35, that means this small area is 0.15. Same will be in this side. Why? Because this is a symmetric one. Okay, now we have all the areas. Now you can find the values. Probability. You have to find the probability. Probability means the area, the corresponding area. So x values in between 20 and 50. So you have to find this area. Okay. You can see it's 0.35. Part B, probability of x greater than 80. This is 80. You have to find the corresponding area greater than 80. So only this small part.
0.15. Then part C, the probability of x values less than 20. So here it's 20. So x values less than 20. So left side. So this small area. Because the probability means the corresponding area. So if you want to find the probability, that means you have to find the corresponding area. So it's again 0.15. Then last one, the probability of x values in between 20 and 80. 20 and 80. Okay, so you have to find this area. Okay, so 0.35 plus 0.35. So it's 0.70.
Okay, here I missed that less than symbol, okay, but it's in your question part D. The answer is correct, 0.70.